AB Calculus Note Card 12, Tangent Lines. This is the 12th video lesson in the series that's inspired by the development of Stacy McMullen, formerly of the Dallas Independent School District, for Note Card system. Here we have Note Card 12, Tangent Lines. Here the tangent line is the graph of a locally linear approximation of a function near the point of tangency. And the thing it says here, it says near the point of tangency. I am tempted to revise that to say at the point of tangency. So if you have a graph here, XY coordinate, then you have there's a curve. There's a point of tangency along that curve. Okay, so the tangent line will touch the curve at that point. So at says near at the point of tangency. You may have to find the y value of the point, and this brings out a point. What you need to create a tangent line is you need a point and you need a slope. All right, so you need those two things, and then the steps 1, 2, and 3 show you how to get both of those. In step 4, substitute the given point and slope of the derivative at that y value into the point slope formula, which is y minus y1 equals m, which is the slope, times x minus x1. Now we're going to work out a few problems showing how to do it. Problem 1, let f be the function defined by f of x equals 4x cubed minus 5x plus 3. Find the equation of the line tangent to the graph of f at x equals -1. Now, I like to tell my students, when you are working a problem like this, you just label what you need to go get. So you need a point, an x-coordinate, a y-coordinate, and you need a slope. And the slope, I like to say m. I like to describe a slope as m sub t, okay? M sub t, t being for tangent line. And so the first thing we're going to do is find the point. Now we already know that we have from the problem an x-coordinate of -1. And now we need to find a y-coordinate to go along with that x-coordinate. So we take the original function, f of -1, and that is equal to 4 times -1 cubed minus 5 times -1 plus 3. And said -1 cubed is -1 times 4, so we get -4, and then -5 times -1 is going to be plus 6, and then we add 3. So -4 plus 6 is 2, plus 3 is equal to 5. So 5 is our y-coordinate for the point. Now we're going to find the slope. The slope we get by taking f prime of x, finding that from the original function. So using the power rule, we have 3 times 4, which is 12, x to the power of 3 minus 1, which is 2, and then we have the derivative of minus 5x is minus 5. And the derivative of 3 is 0, and so nothing needed there. So we're going to find f prime at the x value of x equals -1. So you have 12 times -1 squared minus 5. Well, -1 squared is 1 times 12 is 12, and bring down over minus 5, which equals 7. And that's going to be our m sub t. So m sub t equals 7. Next, our point slope form, y minus y1 equals m sub t times quantity x minus x1. And so the point here is x1 comma y1. So we're just going to fill in the numbers. So we have y minus y1, which is 5, equals m sub t, which is 7, times x minus negative 1, which simplifies to plus 1. So this will be our equation. Next, problem 2. Using the table below, find the equation line tangent to h of x at x equals 8, provided h of x is a differentiable function. So in a table, we need to be told that we have a differentiable function. So again, same thing we've done before. Point. We get x coordinate, y coordinate. And then slope, m sub t is equal to question mark. Well, we want to know the equation of line tangent to h of x where x equals 8. So 8 will go right in here. And next, we want to find h of 8. Well, here's our x value, and h of 8 is 9. So there's the input value, 9. So we got our 9 for our y value. And next, our slope is going to be h prime of 8, which is negative 4. And again, using the point slope form, like we did in problem 1, we have y minus y1. Okay, y1 is 9, x1 is 8. So we have y minus 9 equals m sub t, which is negative 4, times quantity x minus y minus x1, which is 8. And so there we have our answer. Okay. Gathering from a table. 3, if the line tangent to the graph of the function at f at the point 1, 7 passes through the point negative 2, negative 2, then f prime of 1 equals. And so what we need to do is essentially we're given an average rate of change, and we know the slope at that point where f equals 1 is going to be equal to that average rate of change. And so if we have like x1, y1, and then x2, y2, we can use the slope formula to find the average rate of change. So m equals y2 minus y1 over x2 minus x1. And to bring that out, we have m sub t is equal to y2, which is negative 2, minus y1, which is 7, over x2, which is negative 2, minus x1, which is 1. So what we have here is negative 2 minus 7, which is negative 9. In the numerator, in the denominator, we have negative 2 minus 1, which is negative 3. So m sub t equals negative 9 over negative 3, which is 3. So therefore, f prime of 1 is equal to 3. So that's problem number 3 again, actual AP test problem. Problem 4, which is a calculator problem. Find the equation of line tangent to the graph of fx equals x to the 4th power plus 2x squared at the point where f prime of x equals 1. So what we're going to do is find the first derivative of this function here. This is a little bit different when we've been doing. So what is the first derivative here? Well, that's going to be 4 x cubed plus 2 times 2 is 4x. And then we say where f prime of x equals 1. So we need to go ahead and take this 1 and plunk it right here. Okay? So we have 1 is equal to 4x cubed plus 4x. Next, we're going to find this, and this is a calculator problem. So I'm going to go ahead and try to solve by graphing. And to do that, I'm going to make a function out of this and say 0, solve one side of the equation for 0. 0 equals 4x cubed plus 4x minus 1. And so if we graph the function f of x equals 4x cubed plus 4x minus 1, and find where the graph touches or crosses the x-axis, that will give us our needed x value. So let's go to our calculator right here. So we enter 4x cubed, there we go, plus 4x minus 1, and we graph this and we see that we cross the x-axis here between x equals 0 and x equals 1. Now to find out what it is, I'm going to go to Menu, Analyze Graph. We're looking for the 0. It says lower bound, question mark in the lower left corner. I press Enter, and I go to the right. I have this 0.237. Well, this 0.237, if I hold the hand over it, I should be able to get more more decimal places, because that's very helpful on these AP tests. And so I'm going to go press the plus, so I get several more decimal places. You see, you can go way out there. So I'm going to go take 0.236733. I'm going to go out 6 decimal places, and I'll explain why I do such a thing. Okay, so here, point, I say 0.2366733. Okay, so let's go ahead and get the y value. For the y value, we're going to plug that value in to the original function, Control I, and we're going to say 0.236733, and then I'm going to press Control var, and then solve, put in x. So we've stored this value for x. Now I'm going to type in the original function, which is x to the 4th power plus 2x. Actually, no, 4x to the 4th power plus, what was that, 2x squared. And we do that, we get this value, 0.115226. Okay. And then our slope, well, we already know our slope because we're given that initially, m sub t is equal to 1. And now our point slope formula, we have y minus y1, so y minus, and this y1 is here, the right coordinate, x1 is this 0.2 business. So we have minus 1, 1, 5, and I'm going to round to 3 places here, equals m, and m is just 1, right? 1 outside here. And we're going to have x minus, I'm going to put 0.237, I'm going to round. Okay. And so that will be our equation right here. Now, why did I go out so many decimal places? The reason is I had to use this 0.236733 as a preliminary value to figure out what y1 was. And so I want to get a very accurate number, especially first, because in the AP test grading, they're going to go to 3 decimal places. So we got to have, the more accuracy you get isn't going to hurt you at all. So anyway, this is a video lesson on tangent lines. The next one will be on normal lines. Good luck, and thanks for viewing.